In this question, I'm going to find the volume of a sphere between two parallel planes. Okay, so I'll take the quadrant of the circle to be x. We are taking the quadrant of the circle x square plus y square equal to a square, rotating about the x-axis. So we are taking rotating about the x-axis. So when this sphere is, if we take the whole quadrant, okay, if you take the first quadrant, okay, and you rotate the circle, part of the circle, x square plus y square equal to a square, then we'll get nothing but we get a hemisphere. Okay, but we'll take two planes here. So we are taking two parallel planes whose distance from the origin are given to be nothing but OP is equal to x1 and OQ is equal to x2. So if you look this diagram, so this, suppose if you have, this is your circle. Okay, I'm taking this is my circle. This is my circle here. I take two planes. So I take this is PQ, OP, and this I take as OQ. So what figure we are getting here? We are getting the figure of this type. Okay, we are getting the figure of this type. So first of all, we try to find what is this. Okay, we try to find the volume of this figure. Okay, we are trying to find the volume of this figure. So here we'll try to find the volume. So volume is equal to pi x1 to x2 y square dx. Okay, so pi y also from the same way like we had done in the previous video. So y square is a square minus x square. So we get here a square minus x square. Now you put this, we get a square. If we differentiate, if we integrate this, we get x, a square x, and if we integrate this, we get nothing but x cubed by 3, x1 to x2. First, we'll put the upper limit, so we get a squared x1, a squared x2 minus x2 cubed by 3 minus, take the lower limit, so lower limit is x1, so we get a squared x1 minus x1 cubed by 3. So we get a squared x1 minus x1 cubed by 3. Now you can multiply this minus here, so plus into minus we get minus, minus minus we get plus. Now we can take common between these two, a squared, so we get x2 minus x1, and this is plus. I'll take minus common, so we get here, we are taking minus common, and we take 1 by 3 common, minus 1 by 3 common, so we are getting here x2 whole thing cube minus x1 whole thing cube. So we apply the formula of a cube minus b cube. So here I'm applying the formula of a cube minus b cube, so we get this. So we can see that I can take common this, so I'll take common this throughout, so we get a square minus 1 by 3 x1 square plus x2 square plus x1 square x1 x2. Now, okay, so this part, so this is between the two planes, so this is a volume between the two planes. Now if we take x2 equal to a, then the part of the sphere will become a spherical cap. Okay, if we take x2 equal to a, then the part of the sphere will become a spherical cap. So you can see here, see this diagram here, we are taking this is x2. Okay, so this x2, if I shift this x2 to this part, okay, if I shift this x2 to this part, then it will be nothing but like a cap. So we are getting a cap, spherical cap. So the figure will be of this type. We are getting a spherical cap, and this coordinate is x1. Okay, this distance is from x1 from the origin, and this is, we are getting the figure this. So when we rotate this, it will become a spherical cap. So let us put in place of x2, wherever x2 is there, let us put a. So we get here a minus x1, a square minus 1 by 3 x1 square plus a square plus a x1. Okay, now if we take x1 to be 0, now if we take x1 to be 0 here, if we take x1 to be 0, this spherical cap will change to a hemisphere. Okay, this spherical cap will change. So this x1, this one, this is your x1, you try to shift to this. So if we shift this one to this, we get something of this type. We got something of this type. Okay, so this radius is nothing but a. Okay, so when you rotate this figure, you will get nothing but you get a hemisphere. Okay, so let us put in place of x1 0. So we are getting this pi a square minus 1 by 3 a square. So you do the LCM, you get 2 by 3 pi a square. Okay, so I took 1 by 2, so I had to multiply here also 2. So 2 into 2 we get 4. So 4 by 3 pi a square. So this is the volume of the sphere. So we get half into volume of the sphere. So volume of the hemisphere is nothing but half into volume of the sphere. Thank you.